आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
The question is, the number of following statements is or are correct. Means how many statements are correct? First, greater the stability constant of a complex ion, greater is its stability. So let's first discuss what is the meaning of stability constant and stability. For example, if a metal complex is present, like this, and a ligand comes. So what does it forms? This complex, metal ligand complex. When another ligand comes, then what forms? This thing. Then the third step, another ligand comes, this process goes on until nth step. Okay. In the end, this complex is formed. Now, we have to discuss the stability of the complex and the stability constant. So let's start. If we have n steps and we sum up all the steps here, if we sum up all the steps here, we will get this thing. Right? Now, if we name stability constant here as K1, here as K2, here as K3, here as Kn-1. So in the final step, the stability constant will be beta, and beta is equal to this thing, right? So as we can see, more the number of steps, more will be the stability constants will be there, and more will be the value of beta. So the statement is correct. The greater the stability constant, greater will be the stability, right? Second statement, see what will happen. In the second step, what will happen? If we see that there is a energy band between T2G and EG level. In T2G level, the two orbitals, and in EG level, the two orbitals, and in T2G level, three orbitals are present, and there is an energy gap between them, which is known as crystal field stabilization energy, or delta naught, right? So now we can see the configuration D4 to D7 is stable in case of strong ligands, strong field ligands, and not stable for weak field ligands. Why? because in the case of strong field ligands, the electrons will remain in T2G level and the crystal field stabilization energy will be higher. If they remain in this level, the crystal field stabilization energy will be higher. So that's why D4 to D7 configuration will be higher for the strong field ligands and not stable for weak field ligands, because weak field ligands will not do the pairing and they will cause the electrons to go to the EG level, which is not stable, and where stabilization energy will tend to decrease. Here the CFSE will tend to decrease. Okay, so that's why you can say if we have ferrocyan and if we have ferricyan. So in ferricyan the electrons will be less. The electrons less, it means they have tendency to go in lower energy T2G and more CFSE will be there. So higher the charge, higher will be the CFSE. Also the attraction between the metal and ligand atoms will be higher. So that's why our second statement, that greater the oxidation state of the central ion and greater the stability complex, yes, this statement is also correct, because as we have greater the oxidation state, there will be more attraction between the metal and the ligand atoms. Also the electrons will tend to stay in the T2G level or in the lower energy state, and their crystal field stabilization energy will be higher. Now the third statement is saying CO stabilizes the complex because of the synergic bonding. CO means carbon monoxide. So as we see carbon monoxide, so the first two statements were for this explanation, the first explanation and the second explanation. Now the third explanation for the CO. In CO, carbon monoxide, metal, carbon monoxide tends to do pi bonding, and due to pi bonding, what happens, that the metal gets filled. Metal deficient d orbital gets filled and partial double bond character arises between the ligand atom and the metal atom. So the bonding becomes strong. The strong bonding will take place. Okay. Here the back bonding also take place, because if the metal atom has electrons in its d orbital, if the electrons are there in the d orbitals of metal, they also tend to form back bond with CO. That's why CO stabilizes the complex because of its synergic bonding. Now chelate complexes have low stability constants. Chelate complexes means the ring forming complexes, means the ring forming ligands. Okay, for example, we have seen the example of ethylene diamine, right? In case of ethylene diamine, it is a chelate forming compound like En. Ethylene diamine is the electrons present on the nitrogen atom bonds the metal and forms a ring. So chelates means ring forming ligands. Now the ring forming ligands are stable because if we have this compound, for example, if we have metal which is bonded with En here, and if we have a metal bonded with ammonia, so the chelate complex will be more stable. This complex chelate will be more stable. Hence, the statement saying chelate complexes have low stability constant, it is not correct. It is not true. Rest of the statements are correct. So answer is option A, B, C are correct ones. We have our A, B, C as the correct options.
क्लास 6 से 12 से लेके नीट IIT जेई मेंस और एडवांस के लेवल तक 10 मिलियन से ज्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।